And we are on the air. Happy Friday, everybody. Today is July 21st, and this is episode 30 of Get Your Tech On, our show on all things DOCSIS. I'm Brady Volpe, founder of the Volpe firm and Nimble This. With us is John Downey, the Iron Man of cable. John is also CMTS technical leader at Cisco Systems. Welcome, John.
Yeah, thank you very much. People ask me, I checked in, they're like, what's your name? I'm like, John Downey. I said, my brother is Robert Downey Jr. He's Iron Man. I'm like Titanium Man. So
yeah. Actually, I like the Iron. Mia comes up with these things. So Mia always puts. She does pre and post production of all these and creates the podcast. But she comes up with these. I like the Iron Man of cable. You want to go with Titanium Man of cable?
Titanium Man. I can't do Iron Man because Robert Downey Jr. plays Iron Man.
Okay, we got.
I looked up his name, Robert Downey Jr. His middle name is John.
No.
Yeah, look it up. Google it. Google that.
That's funny. That's a good coincidence, man. Cool. So today's episode, we're covering the last part, the third part of John's best practices on DOCSIS CMTS. So if you've been following us for a while, we're now on episode 30. We've done 30 of these things, John, over this like the past 2.5 years, I think, because we do on average about once every month. Yeah. Even though we've had some requests from our listeners to do once a week, we cannot handle one show a week. One a month is good. But over the past, I think we did the first one like in January or something, December. Then we did part 2, somewhere in March. And now we're on part 3 of you have like a really nice PowerPoint deck on these best practices for DOCSIS CMTS. So finally we're on the final part of it, which kind of gets into some more of the advanced areas of, well, we'll get into these. We'll go through each part of it, but I'm kind of excited about this. I don't know, is there anything we want to cover before we get into this best practices, John?
Any conferences that have come up, or have you done any local SCTE chapters?
I haven't done any local SCTE, but I do want to give a shout out. I was up in the north. I don't want to mention any specific systems. I want to give a shout out. I was with a great group of customers up north this past week. Fantastic folks. I want to give a shout out to all you. I know a number of you are going to be listening today. You guys are fantastic. I really, really enjoyed spending the time with you. And we did some training. We had a really nice day, a nice dinner. Great spending time with you folks. Hope you're listening. Hope you continue listening. And just thanks for spending all the time with me that you did. It's a great time. So just giving a shout out to those folks.
Nice.
So that's all. I think, we're kind of getting into the doldrums of summer here. Everyone's getting on vacation stuff. We're not going to have a show in August, I don't believe. I think the next one's going to be scheduled probably the week or two after Labor Day weekend. Okay. So that's our. Okay. And for those of you that aren't in the U.S., Labor Day weekend is like the first weekend in September. So that's a U.S.
3rd.
Holiday.
Yeah, September 3rd, I think it is.
Yeah, something like that. So how about you, John? Have you done any SCTE shows or any?
The local chapters, we try to do WebExes. It's just as easy to do a remote WebEx, especially for a presentation. Now, for me, I like doing whiteboarding. So it's tough to do a whiteboarding session and fly, go segue into different things like I do. And
you just like to smell the markers.
Only if they're flavored, like the blueberry ones. But we'll do some remote stuff, and I think it actually helps some of the techs that can just watch it later. It's recorded, and then they can stay at home and watch it. When we would go to some of the local chapters, the systems can't afford to take their techs for an entire day. So as a presenter like you and I, we might have to do the same session twice, right? Which is okay. But it becomes difficult too, because you forget like what you talked about in the first half versus the second half, and it comes you become a little redundant. It's like, I want to put all my energy into one presentation and just be done with it. So it's difficult. And then how do you justify it? Flying to Oklahoma or wherever for 1 hour or 2 hours. I could talk for half a day, but nothing's been coming up lately. Getting prepped for SCTE Expo in October in Denver. I just submitted my presentation for that, DOCSIS 3.1 downstream lessons learned. And I'm sure that's probably what you and I might talk about, say, in the August timeframe or September timeframe, our next hangout. Maybe we'll use these guys as a sounding board.
Yes.
What we could do is we could do a quick presentation, because really I only get 15 or 20 minutes at Expo. Maybe we do that in September, and then people can give us feedback for what I can throw into it for the October Expo. Yep. I don't know. We can see how it goes. Other than that, I mean, things are busy with DOCSIS 3.1. Remote PHY is really starting to catch hold, at least for people's interest in remote PHY and the architecture and what does it really bring to the table. But DOCSIS 3.1 downstream, we have a lot of lessons learned now. We're now getting into, say, a little bit of upstream, DOCSIS 3.1 upstream. And that's going to be interesting. I have a few ideas on the upstream as well.
So you're talking about OFDMA in the upstream for DOCSIS 3.1, right?
Correct.
So are there field deployments? I mean, are you seeing field deployments where it's OFDMA, or this is more lab work that you're seeing?
More lab work. I mean, you think about it, people have very limited upstream spectrum, and no one has code yet that I know of that will do TAFDMA, time and frequency division multiple access. Right. So you have to really allocate spectrum for 3.1 and allocate spectrum for 3.0 and 2.0, and there is no spectrum. I mean, 5 to 42 megahertz, where's your spectrum? So if you're doing a 5 to 85 megahertz, yeah, we could do it. But 5 to 42, I'm not really seeing how it's going to help me until I can share that spectrum, time sharing.
Right.
And the only reason to do 3.1 upstream is because you really need higher speeds in the upstream. Until we start reaching, say, 200 meg in the upstream, 100 meg in the upstream, with 4 ATMA, you can get 108, so you could offer a 50 meg service. Some people might offer a little bit higher, but to offer 100 meg service, you could still do 8-channel upstream bonding if you have 5 to 85.
Yeah, and actually, I know of a number of customers that are getting to the point where they're doing 8-channel bonding in the upstream. They're doing it because they're using smaller channels because of noise in the upstream. So that's the reason they're doing 8-channel bonding.
So they're doing 8-channel, but 3.2 megahertz wide channels.
Yeah, and when you get down to the lower frequencies, they're going even smaller than 3.2, and they're finding success with that because they have really noisy returns. Yeah. They're going to the smaller channel bandwidths and being able to get more noise through, or more bandwidth through on the smaller channel bandwidths. Yeah.
The problem I see with that is you are paying a flat rate for that upstream channel. At least from our side, it's a license for the channel. Using that channel at such a small capacity, you're wasting money. In my mind, you're wasting money. If you did a 6.4 megahertz wide channel, you pay X. You do a 1.6, you pay X. So I should do 6.4 versus 4 1.6s.
Yeah.
You understand?
Yeah, no, that's actually a very good point to communicate to folks that the licensing cost is something to really consider. Maybe spend a little more time trying to get the noise down, or just got to focus on that.
But I understand also that the reasoning of going from 6.4 to 3.2, because we keep same average power, that 3.2 will go up by 3 dB. So you gain 3 dB of carrier to noise ratio. You go to 1.6, you go up another 3 dB. So now you gain 6 dB in robustness. You do 16 QAM, you gain 7 dB in robustness, or 5 dB in robustness versus 64 QAM. So yeah, I can understand going to smaller channel width. And by the way, 3.0 basically made 0.2, 0.4, and 0.8 a may, not a must. And so we don't even support those bandwidths anymore. And if you were using a 0.8 megahertz wide upstream channel, you shouldn't be doing DOCSIS. I would just filter out that spectrum if it's that bad.
Yes.
If I had my way, I'd filter out the low spectrum at the fiber node to help alleviate upstream laser clipping. If I still had, especially FP lasers.
Right.
I'm assuming most lasers are DFB, but if we get digital, much better.
This system does not
have
have
FP
Fabre Pro lasers when they're running that much DOCSIS on the upstream. Because the older FP lasers, as I think what you're implying, that's going to experience laser clipping. And definitely. So it's going to have problems.
But it is funny you mentioned the 8-channel upstream bonding, because that actually segues into some of our best practices. So why don't you throw up the slides, and then we'll go right into, I think we left off at getting down deeper, the devil's in the details of the cable interface.
All right, so I'll be happy to do that. We have the slides up now, and for those that are just listening to the audio, the slides are kind of just for people that are watching and they want to read it, but if you're listening to the audio podcast only, you're still going to hear everything that we're talking about here. So we have a slide up right now that says cable interface configurations, and now John's going to start talking to the bullets that are on there. So John, please proceed.
So the bullets here are really to focus on we call the MAC domain, the cable interface configuration. A MAC domain is a set of downstreams and upstreams that the modem can listen to and transmit on. You can do load balance from within the upstream and the downstream and all that. Now, there are some commands that go under this cable interface that, by default, they might not be the best. Normally, you'll have default settings that will make your system run appropriately for 90% of the systems out there, and that's why you make them defaults. But once you understand how your system really works, you might be able to tweak some of these things, and that's where we come up with best practices. And I usually tell people, I was like, here are the pros and cons of doing different settings, and you make a decision, is it worth it or not worth it? I don't know what your network looks like. I don't know if it's a node +5 architecture. I don't know if it's 550, 750, 860 megahertz system, 1 gig system. I don't know if it's digital upstream or still analog upstream. So there's a lot of things I have to take into consideration. So this slide is kind of an agenda sort of what's coming up. I talk about some commands called power adjust continue, a command called max channel power offset, upstream balance scheduling command, a SID cluster command, whether or not you're going to do 4 or 2 channel upstream bonding. Like a lot of people might do two channel bonding groups inside the 4 channel bonding group, and there's a reason why you might do that. And how does upstream bonding partial mode work? How do I move my service flows if I do go into partial mode? And also map advance. Map advance is one of those things that's highly misunderstood, and you can optimize the map advance for different node architectures, meaning the optical link loss and link budget. So let's go to the next slide, and I actually show an example. Yeah, go ahead.
So the one thing I want to ask is, when we talk about like power adjust continue, my mind would automatically think this would go apply to something like station maintenance. Station maintenance being when the modem every 20 seconds checks in with the CMTS and says, how am I doing? And the CMTS looks at that signal and says, well, you need to adjust your power level a little bit. You need to adjust your frequency. Your timing needs a little adjustment. And all the modems are checking in with the CMTS every 20 seconds. And they're kind of doing these adjustments all the time to ensure that all modems are at the right power level, frequency, and maybe even making pre-equalization adjustments. Is that
Correct.
what these interface configurations are doing? Is that for station maintenance?
Well, at least for that first one, for the power adjust continue. I mean, once the modem is fully registered, let's suppose the modem's fully registered, upstream levels look fine, you want to have a sort of a band-aid on the CMTS that allows the modem to stay online even when the temperature fluctuates. And especially right now, this time of year, I mean, sun-loaded, black-jacketed cable, my God, that's like 40 degrees over ambient temperature. That's a rule of thumb. So it's 100 degrees out right now in North Carolina. So that's 140 with black jacket sun-loaded cable. So the attenuation of the coax is going to go up a lot. The attenuation goes up, CMTS sees lower level, CMTS tells the modems to transmit higher. But what if that modem is already at max transmit? Now the modem can't transmit higher than what it's capable of. So it maxes out at, say, 4-channel upstream bonding, 51 dBmb per channel, because it's doing 64 QAM. So it's at 51 max, hits the CMTS at -3. Well, maybe hitting the CMTS at -3, the MERs really aren't that bad. So why not just let the modem stay online? Why would I say, oh, you're outside this window of ±1, so let's make the modem re-register? That would be crazy. So we're like, let's put in a kind of a catch-all or a band-aid in the CMTS to allow these fluctuations in levels and let the modem stay online. And if the MER is bad, well, then eventually it has uncorrectable FEC. It might go into partial mode, but we can have that modem stay online. Yes, the MERs for that specific modem might be lower than the other modems that are hitting the CMTS at 0. These ones are hitting at -3, -4. So the power adjust continue, our default from Cisco is 4 dB. So if your default level to hit CMTS is 0, anything from 0 to -4 will let the modem stay online. But I recommend we do 6. So 6 dB is 4 times more power. Every 3 dB is double power. So 6 dB is nice. Some people have gone as far as 8 to 10 dB, but I don't like to push my luck. If you let a modem stay online and it's hitting at -10, that means it's even closer to the noise floor. So his MER is much worse than everybody else's. He might be dropping getting a lot of uncorrectable FEC. if you have enough of those devices in this power adjust window, you could have more station maintenance bursts happening over and over and over again. So it's a lot of entries in the flap list for power insertions in the flap list. So you have a lot more activity in the flap list. I also find that if you let a modem hit the CMTS and say -10 and stay online, what happens if a modem is, say, in the head end and you're using it as a test modem and it's hooked up to Upstream 1, but you didn't really put in proper padding to force the modem to transmit at, say, 45 dBmV, and the modem comes up on Upstream 1 at, say, 30 dBmV. So that modem registered fine, 30 dBmV, but what if, like, how much range does that modem still have left if it ever goes offline and comes back and starts ranging on Upstream 0? 30 dBmV,
it could go all
range
the way to like 50,
55, 60 almost.
Sometimes with the extended transmit power could go to much higher.
So it has so much reserve left, it could potentially find another path in the head end because of combining splitting architecture, that it actually finds a bleed over path to get over to Upstream 0. So now you have a modem that registers on an Upstream port you didn't think was actually physically connected. But it is physically connected because of your splitting combining, meaning your splitting combining is different for different services. Your sweep gear, your high-speed data gear, your voice, your set-top boxes. So if you draw out the actual flow diagram of all your connectivity, you might find that modems have another path and overcome port-to-port isolation. And then if you do power just continue 10, you just gave that modem 10 dB more range to register on an Upstream port. Right. So it might do a NIDR1, and maybe it gets stuck in NIDR1. It might get to a NIDR2, but then it can't fine tune, so it actually goes offline. So you're scratching your head trying to figure out, why is this modem like going NIDR1 and NIDR2 offline? Then eventually it actually comes up on the proper Upstream.
Right.
So there's a lot of stuff like that. This is part of best practices.
Sure, of course. All right. So thanks for clarifying that. So you're ready for the next slide now, yes?
Yeah. Yeah. So this next slide goes into the actual cable interface configuration, and we'll kind of talk through some of these settings. So at the very beginning, there's a load interval command. That default is 300 seconds, so that's 5 minutes. I found that depending on the iOS code, this command will affect my Upstream utilization reporting for load balancing, and it's a best practice for me to set this to 30 seconds, which is the lowest setting. I want my rolling time average window to be a 30-second rolling average instead of 300 seconds. And the reason why is, if you were doing Upstream load balance between Upstream DOCSIS 2.0 and a modem moves from one Upstream to another, but the utilization doesn't actually catch up for 300 seconds, load balance is like, oh, now I need to move another modem and another modem. Well, the utilization is still not balanced, so let's move another modem.
So is load interval, is that looking at the utilization, or is it looking at how frequently we move cable modems around? I mean, exactly.
No, that's not the load balance interval. So load balance interval is the interval for load balancing. So that's a different that's a load balance interface configuration. This command affects how the utilization is being reported.
Okay.
It has nothing to do with it's not a load balance interval, but it's affecting how the utilization is being reported, which then load balance could be affected by.
Right. So this is how often basically we're going out from a monitoring standpoint within the CMTS or CCAP and looking and saying, well, what is the load on the CMTS or CCAP?
Correct. It's not a polling interval. We're not saying we're polling every 30 seconds. It's basically, give me the utilization averaged over 30 seconds. Okay. Now that could be polled every second. It could be polled every 5 minutes. But that instant that you grab the information, it's a 30-second average.
So yeah, so it's almost like, what is the average load over 30 seconds versus what is the average load over 300 seconds? And you're saying the default is 300 seconds, which much greater time frame. So you're not seeing the fluctuations as great because when you do it at 300 seconds, because it's a much longer averaging period. You're kind of smoothing out that load.
Exactly. So you could have utilization going to 100% and 0%, 100% 0%, but it averages to 50.
Right.
So that's why I say, people talk about load balancing and utilization reporting. I'm like, yeah, but what time frame are you talking about?
Yeah. So if say you did a load interval of 24 hours equivalent, whatever that works, that's, I forget how, 3600, no, I forget how many seconds that is. But anyhow, if you did like, load interval 24 hours, you would never see the peak traffic that occurs typically on any cable system from 6 p.m. to midnight or something. So you would kind of miss the fact that, you might have some load average throughout your system, but you wouldn't be moving modems around between 6 p.m. and midnight when you really have the heavy load. You'd just be it'd be a static system.
Yeah, you have a lot of congestion happening, customers complaining, but then your reporting would say everything is fine.
Yeah. Okay, that totally makes sense.
All right. So that's the load interval, and I recommend setting it to the lowest setting of 30 seconds. Some people might do 60 seconds, say 1 minute, or it's really up to them. As you go through my configuration, I have the power adjust continue of 6. The default's 4, but I say, open it up to 6 dB. Give yourself a little bit more breathing room for modems to be able to max transmit and still stay online if they're between 0 and -6. Mm-hmm. We have another command we came up with, what's called cable upstream balance scheduling. It's not on by default, and I recommend turning it on because it allows my upstream bonded traffic to be more evenly distributed across all the upstreams of the bonding group. If we look at my configuration further in, I have a 4-channel upstream bonding group, and then I have a 2-channel upstream bonding group as well. And I'll explain why I have those two. When I look at the upstream balance scheduling command, it helps to distribute the mini slots evenly across. So if a 3.0 modem says, hey, I need 100 mini slots, it would evenly distribute 25, 25, 25, 25. That way, upstream 0, 1, 2, and 3 have an equal number of mini slots allocated, and my utilization appears a lot more evenly distributed. What we found out is without this command, upstream 0, or the first upstream in the bonding group, was getting more hit or more utilization than the others. And you could argue that that's okay as long as there's no congestion, because our scheduler was basically saying, throw a bunch of mini slots in upstream 0. I still have upstream 1, 2, and 3. If I make all the mini slots contiguous in one scheduler, I have less chance of jitter, less chance of latency. There's no need to schedule more in upstream 1, 2, and 3 because upstream 0 is not that congested anyway. And if it does start getting congested, we'll just schedule more in upstream 1, 2, and 3. Well, this became a problem for, say, people's reporting. They're like, hey, this is looking awfully strange because upstream 0 is always at 80%, and the other one's at 40, and the other one's at 20 and 20. It's like, how do I make this look, the quote unquote look or appear more evenly distributed? And so we came up with this command to make it more evenly distributed and also report based on a 30-second rolling window as well. That way it's evenly distributed, because if it's not, and it's 3.0 traffic creating an imbalance, then DOCSIS 2.0 load balance could kick in. Because it makes it, then 2.0 might say, oh, I need to move modem from upstream 0 to upstream 1 because upstream 0 is congested.
And that command is cable upstream balance scheduling.
Yes.
Right? And so you're saying that will evenly distribute the traffic from upstream, instead of having all the traffic kind of generally hanging out on upstream 0, that evenly balances it across upstream 0, 1, 2, and 3 when you're doing
Correct.
upstream load balancing.
So it's not on by default, so I recommend that people just turn it on, and then you'll get your upstream to look more balanced and evenly balanced.
Now, I do have a question. Let's say you didn't have that command on, and all of your traffic was on upstream 0. What would be what would be your recommendation to set your frequencies for upstream 0, 1, 2, and 3? Would upstream 0, should that be your lowest frequency? Or should upstream 0 be your highest frequency?
I had this debate also as well, where before we had this command, I said, if the scheduler is kind of round robin assigning mini slots on the upstreams and it's going from 0, 1, 2, 3, 0, 1, 2, 3, you definitely don't want to make upstream 0 one of your smallest channels. Like if you were doing mixed mode or bonding with a TDMA and ATDMA, you definitely don't want to make upstream 0 TDMA. You want to make upstream 0 the biggest channel possible. You understand?
And is you want to make it right. You want to make it big because then it's going to handle the capacity better, right?
Correct. Frequency-wise, you might say, well, I want to make sure it's one of my cleanest frequencies, but remember, it's just the CMTS is scheduling mini slots, but if it does get slightly congested, it'll just then start moving over to upstream 1, 2, and 3. And it is round robin assigning through those upstreams, but it just turns out it's assigning more to upstream 0. So with that in mind, I either use this command, cable upstream balance scheduling, and even it back out. But if I don't have this command, just make sure upstream 0 is a good frequency and one of the biggest capacity channels you have.
Yeah, I mean, what I'm thinking about is if I know that the probability that my greatest amount of traffic is going to be on upstream 0, kind of assuming I don't have this command, maybe because I'm running an older iOS version or software version on my CMTS, then I start to think, well, maybe I want to put upstream 0 at a higher frequency that's generally going to be clean, right? I don't want it to be down at 19 megahertz or 17 megahertz where there's going to be a ton of noise.
Agreed. I mean, you might say, all right, I'll do upstream 0. A lot of people used to do like 24 megahertz and then 24 and then 30 and 36 or 6.4 megahertz separation, and then maybe I mean, the assignment of the upstreams doesn't really matter. You could have upstream 3 at the lowest frequency and upstream 0 at the highest frequency, but you might not want to put it at the very high frequency because of roll off. Now, pre-EQ will take some.
Yeah, the diplex filter is going to cause the roll off, which is cause group delay, which that also could cause issues, and so you want to keep it away from. That's actually a very good point. Yeah. So,
and then there's a lot of times that you see modem transmit levels are worse at the higher frequency, right? Because there's more attenuation in coax.
Yeah, that's a very good point. So I think the best recommendation as you're making from a best practices standpoint is just use cable upstream balance scheduling, which then you don't have to worry about it.
Yeah, so, I agree. Point. This is why, this is years and years of experience and looking at different systems and coming up with what we call best practices, from the field. And all you can do is tell people the pros and cons and let them make the decision.
Yep.
The next line was cable upstream ranging init technique 2. Now this one, you don't normally see this command. Even though it's talking about upstream ranging technique, I say it's better for DOCSIS 3.0 downstream load balance. Now, the reason why
oxymoron because it's upstream, but you're saying it improves. Yeah, it's cable upstream ranging, but it improves downstream load balancing. How in the heck does it do that, John?
I know. So when we do DOCSIS 3.0 load balance between bonding groups, the spec says that even if you're just changing a downstream, and this is, well, actually, let's just say DOCSIS 3.0. How do I want to say this? Yeah, you want to change from one set of downstreams to another, but you're physically not even changing upstream, right? Downstream and upstream is independent.
Sure.
So you can move to a different downstream primary in a different group of 8 channels. So you're doing 2 8-channel bonding groups, and you move from one group of 8 to another group of 8. The upstream doesn't even move. But according to the spec, the modem must redo station maintenance, upstream level, upstream timing, upstream, make sure the frequency is good, and pre-equalization.
Right.
What we're finding is when the modem moves, when you have, say, 4-channel upstream bonding, you have to redo all of that readjustment on all those upstreams, and it's dropping, say, maybe 5-6 seconds of layer 3 traffic after a DOCSIS 3.0 move.
Mm-hmm.
It's worse with pre-EQ because the pre-equalization taps have to happen again too.
And if you're doing 2 or 3 or 4 channel bonding, then you have to do the pre-equalization taps for each upstream, right?
Correct. So even though you didn't move anything on the upstream, which I kind of argue with Broadcom that I think it shouldn't act like that. I'm like, I can understand maybe moving to a different downstream and maybe redoing your time offset, but the upstream hasn't changed. You have the same upstream attenuation, same frequency, same timing, same pre-EQ. Nothing has changed on the upstream. All you did was change the downstream. And they're saying that, according to the spec, we're supposed to redo all the maintenance, upstream maintenance.
Yeah, there's probably a very good reason for it.
Yeah, probably.
Because I mean, when you're going from one downstream to another downstream, I mean, it could be on maybe a different transmitter. It could be on a different edge QAM. not, I mean, it could be on the same edge QAM device, but it could be on a different port of that edge QAM. I think there's probably a different, in that case, it would be on a different RF cable. So then you could be dealing in different frequency length or different, distances. There is probably
No,
some
well,
reasoning that went
but
behind that.
that's downstream. And I said, yeah, I agree. Maybe time offsets because it's different downstream. But remember, the upstream hasn't changed, and your physical wiring hasn't changed. But regardless of that, we found that if we change from the default, which was technique 1, I believe it is, and we go to technique 2, according to, it's like DCC techniques. Technique 2 allows the modem to resume layer 3 traffic, and it'll wait for station maintenance to redo the pre-EQ and the level and the frequency and the time offsets.
Yeah. Technique 1 means that the modem basically has to completely go through the whole
initial
registration process, right?
Yes. Well, the modem doesn't go offline, but it has to do the initial maintenance stuff.
Yes.
So it doesn't go offline, but it has to do frequency, time offset, what's the other one? Pre-EQ and levels, upstream levels.
Right.
Those 4 things. So the moral of the story is, if I change it to technique 2, when a modem moves with DOCSIS 3 or load balance, I'm getting layer 3 traffic back a lot faster.
Yeah, and so this is going to be less, from the subscriber's point of view, the probability that they're going to notice any change in service, or any impairment in service is going to be much less than technique 1.
Correct.
Cool. Very cool.
So, yep. The next line was upstream max channel power offset 6. This is a Cisco specific command that we added for DOCSIS 3.0 registration. So just like the power adjust continue allows 2.0 modems and other modems to stay online if they're within, say, 0 to 6 dB, this command, this max channel power offset, allows a 3.0 modem to register properly if it's within 6 dB of the nominal. So if the nominal is 0, we'll let the modem do 4-channel bonding as long as it's within 0 to -6. Because when a 3.0 modem registers, it transmits on one upstream channel. It tells the CMTS its transmit level, and the CMTS decides, hey, is that level good enough if I decide to let you do 4-channel bonding? If it doesn't, then it would force it to maybe single channel or a 2-channel bonding group.
So how does exactly, so we have cable upstream power adjust continue 6, which that allows the modem to stay online if it's within 6 dB of the optimal 0.
So that's for 2.0 modems and 3.0 modems that are already registered.
Right.
And this new command is for just the registration of 3.0 modems.
Cable upstream max channel power offset 6.
Yeah.
So the first command, cable upstream 0, power adjust continue 6, that's if they're already online.
Correct.
Cable upstream max channel power offset 6 is for new DOCSIS 3.0 modems trying to come online. They don't have enough power, or maybe too much power, that they can't meet that 0 dBmV optimal frequency or power level, and this lets them come online.
Correct. I wouldn't say too much power. They don't have enough power. They're already maxed out, and they're hitting the CMTS between 0 and -6. The CMTS will say, you're transmitting 55 dBmV on one channel, and the CMTS is like, well, I see a 4-channel upstream bonding group created, and you're trying to do 4-channel upstream bonding, but according to the spec, max output is 51 dBmV. So if I tell you do 4-channel, you're going to drop to 51. So if you're transmitting 55 and you really should be doing 51, you're 4 dB off. So because the max channel power says 6, that's within that window. You're 4 off, but the window is 6. I'll let you actually register with 4-channel upstream bonding. Yeah, I know you can only do 51. I know you're actually hitting me now. I'd say -4, -4.5, -3.5, -5, but you're within 0 to -6, so I'll let you stay online, and I'll let you transmit and come online fully on the 4-channel upstream bonding.
Okay. I do want to just confirm, you said it couldn't be too much power, but I have seen modems in head ends or off of maybe low value taps where they were actually, for DOCSIS 3.0 modems, their minimum transmit power is, I think, 23 dBmV. That modem will be at 23 dBmV, and at the CMTS, it's sitting there at like 4 or 5, plus 4, plus 5, plus 6 dBMV?
Well, what should happen is the modem's actually kicked offline because there's a minimum. Basically, the CMTS is going to say, all right, drop your level by 4 dB to hit me at 0, and the cable modem can't, so it should go offline.
So even with this cable upstream max channel power offset 6, that doesn't mean plus 6 dBMV.
No,
it's only
one
minus
direction.
6.
Yeah, correct.
Minus
correct.
6 dBMV.
Correct.
What's the maximum positive power you can allow a modem to register with a CMTS?
Well, it sounds to me like you're talking about the minimum, which the spec is 23, right?
Well, the modem's transmitting at plus 23. It's minimum transmit power. So at the CMTS,
that is another command. It's called power adjust threshold. I don't show it on this configuration because the default's plus minus 1 dB.
Okay.
And I don't recommend changing that. So it's nominal 0, which you can change that as well, but nominal 0. The power adjust threshold is 1, which means plus minus 1. And then the power adjust continuous is 4, but I recommend 6.
Right. Okay.
When you're asking about the max positive side, well, that would be plus 1. Plus 1 minus 1.
Okay. Okay, thanks.
Sure. So moving on. So that max channel power offset, I've seen cases where customers can actually set that even higher to have a bigger, say, how do I want to say this, a bigger Band-Aid for 3.0 modems to register properly. So maybe a max channel power offset 8 or a max channel power offset 10. That way the modem fully registers in 4-channel upstream bonding. Question?
Yeah, is there, so if you, in the upstream in particular, and you had mentioned like when you have an upstream, you're doing 4-channel bonding, one of your upstreams is close to the diplex filter, and because of that, because of pre-equalization, it's compensating for some group delay, some roll-off. That channel has to transmit at a higher frequency or higher power level, but when it's arriving at the CMTS, it's gonna be a different level than the other bonded channels in that bonding group. How does that impact the CMTS? Does it, if one of the 4 channels in a bonding group is coming in at a different level, do these commands impact that?
So there's another part of the spec. It's called the DRW Dynamic Range window. All the channels in upstream bonding group have to be within 12 dB of each other. I mean, and that's pretty high, right?
That's significant, yeah.
Now, you bring up a good point about the higher frequency in the upstream having more attenuation. When a 3.0 modem registers for the first time, you don't know which upstream it's going to range on first. And all the decisions from the CMTS are made on that first channel. So if you had a case where a modem ranged on upstream 3, and that upstream 3 had to go through more attenuation and roll off, and that upstream actually ranged at 60 dBMV, the CMTS would say, oh, you're doing 60, and it's assuming all 4 upstreams are going to be at 60. It doesn't know the other frequencies and stuff, right? So it says, oh, 60. Well, I know if you want to do 4-channel upstream bonding, you can only do 51. 60 to 51 is 9 dB. That's out of the 6 dB window. So I'm not going to let you do 4-channel. So let me see if there's a 2-channel upstream bonding group created. And in my configuration, I do. So I have a 2-channel. Well, that gains me 3 dB more. So the modem, according to the spec, can do 54 dBMV. And if I look at 54 to 60, that's 6 dB. That's it within the 6 dB window, very close. That modem actually might register as a 2-channel upstream bonded modem.
So that's why you have a 4-channel bonding group and a 2-channel bonding group in your configuration that you're showing on this screen here. Is that correct?
Correct. And notice I made my 2-channel upstream bonding group with upstream 1 and 2 because I knew how my scheduling might schedule more mini slots in upstream 0. So I'm like, well, if any modems register with a 2-channel upstream bonding group, maybe I'll force them onto nice clean frequencies in upstream 1 and 2.
That's really smart. I like that.
Yeah. So instead of making 2-channel upstream bonding groups, I just made 1.
Right. Yeah, very good. Very cool idea.
So that's sort of the reasoning behind this, of why I'm trying to get modems to register the biggest bonding group possible. I mean, that's the panacea of load balancing, right? Bonding across as many upstreams and downstreams as possible. Then you don't have to move modems. You just spread traffic.
Yeah, because otherwise what I've seen is when a modem can't do channel bonding, it drops back into DOCSIS 2.0 mode because it doesn't have enough power to do the load balancing. In that case, it'll just come on in DOCSIS 2 mode, and you lose all the capabilities that you want of a DOCSIS 3.0 modem.
And let me make this even worse for you. DOCSIS 3.1 modems have to be upstream MTC mode to register in 3.1 mode. So a new 3.1 modem must be able to register in upstream bonding for it to allow it to do downstream 3.1. And
if it doesn't, what does a DOCSIS 3.1 modem fall back into, like a DOCSIS 3.0 mode or a DOCSIS 2.0 mode?
You would think so, right? It's worse than that. I've seen modems just cycle back and forth between registering or a NIDR1 and NIDR2, reject NA offline.
Oh wow! So that's horrible. Then that's like
Yes.
a worst case scenario. The modem won't come online at all, just because it can't do channel bonding.
Correct. So I've seen cases where the upstream level is so bad the modem doesn't register in upstream bonding mode. It could be single channel upstream bonding mode, but it registers a single channel upstream 2.0 mode, and then the 3.1 modem just basically cycles back offline.
Yeah.
So it never fully registers.
Yeah, I mean, I would rather have my 3.0 modem at least come online in 2.0 mode, so now I can troubleshoot it and figure out what's going on. But with a 3.1 modem, it doesn't come on at all.
Yeah.
That's a bad scenario. So
correct. I agree.
Yeah.
So
I see an ECR coming for that one.
So the next line is interesting because you talk about 8-channel upstream bonding. This is called a T4 multiplier. So a lot of people don't understand this one. The modem has a T4 timer of 30 seconds. Now, you mentioned earlier the CMTS sends station maintenance every 20 seconds. Well, our CMTS, when you're doing line card redundancy, we increase that at every 15 seconds. That way, we'd have a 15-second worst case scenario of a modem's 30-second timer running out. So it gives us 15 seconds of leeway. So we send station maintenance every 15 seconds when we have line card redundancy configured on the CMTS. So every 15 seconds, CMTS is talking to every single modem saying, here's your levels, upstream frequency, time offsets, and pre-equalization, if I need to readjust. When you have a modem doing upstream bonding, we have this T4 multiplier according to the spec that's set to 0, which means auto, which translates to how many upstreams in the bonding group. That's the number. Meaning, if I'm doing a modem is specifically doing 4-channel upstream bonding, the T4 multiplier is 4. So that modem has a 30-second timer, times 4 is 120 seconds. This is why a lot of techs out in the field could disconnect the modem's cable, and they're like, why is this 3.0 modem still online? And then I pulled the cable off like 2 minutes ago. Because the downstream will stay locked for 2 minutes now.
Yeah.
Because it's not getting a T4 timeout.
Well, a lot of us take advantage of that feature because I know I can move cables around in the head end without the modems going offline. If I do it within like 20 seconds or so, they stay online. It's a feature.
That's a good news. That's the good news. But if we're not updating our upstream MER, upstream pre-equalization, and levels for 120 seconds, you're not getting pre-Q updates for 2 minutes.
Yeah, so that's actually the bad news for me from a proactive network maintenance standpoint. So this is a nice command. Yeah,
so what I'm recommending, so it gets worse if you do 8-channel.
That's horrible.
If you do an 8-channel, now the multiplier is 8 times.
240 seconds.
Yeah,
right?
That's 4 minutes, right? So you're not getting MER updates for 4 minutes. You're not getting pre-equalization updates for 4 minutes per upstream. I mean, that's pretty bad.
Yes.
As a compromise, I've been recommending that I hard set my T4 multiplier to 2.
Now, is that variable? Could I set that to 4? Which if you're doing 8-channel bonding, I probably want to set that to 4, so I'm getting those updates on the pre-EQ even faster.
Correct. But now 4 times 30, 120. That's 2 minutes. Sorry, I'm chewing on ice. I'm getting myself all heated up.
Titanium, man.
So the whole point of the T4 multiplier was say, well, if I had 500 modems in a MAC domain and I went to 4-channel upstream bonding, you would end up doing 4 times 500, 2,000 station maintenance bursts, even though it's only 500 homes, because you have to do station maintenance in every upstream. So the spec said, well, we'll do a T4 multiplier. But the bad news is that's creating more lag in the updates from my upstream MER, my upstream level adjustments, and my upstream pre-EQ. And like you said, I think pre-EQ is kind of important,
Yes.
you know?
But when we do this, aren't we creating more congestion on the upstream and downstream, because these are a lot of station maintenances messages coming from the cable modem to the CMTS in a form of a station maintenance request, and then a response from the CMTS to the modem, a range request, range response.
So I know you're throwing me like a softball there, because I know you should know the answer because you work for Filtronic SigTech, and you know these station maintenance perks are tiny compared to everything else. It's probably like 1% overhead. So and I know you're setting me up, that no, I'm not concerned that this is going to cause congestion.
It's in the noise floor.
Yeah, exactly. Especially since we're going 6.4 megahertz wide upstreams, ATMA. It makes it even less percentage overhead, right? Because it's still the same. It's not a concern.
No, it's not.
Now, if I was doing thousands of set-top boxes and 8-channel upstream bonding, and I had, let's say, 2,000 devices on the MAC domain, but it was making it look like 8,000 devices, then maybe I would be a little concerned. Like,
yes.
If I'm trying to do so much, what happens if I drop a few? Does it have to wait or go around again? But with the way we're offering speeds today, the number of devices per service group is becoming less because we're trying to offer higher speeds.
But station maintenance, ultimately, it's got nothing on Netflix traffic.
Touche. So this is why I say, the T4 multiplier, I think setting it to 2 is kind of a nice compromise.
Yes.
I'm still getting multiple T4 timers. I'm getting a little bit more often. I'm getting updates better for my upstream MER, upstream levels, and upstream pre-EQ information.
Very good.
The next one is something that's not on by default, the next 3. When a modem goes to upstream bonding partial mode, like maybe the CMTS says, hey, your levels are bad or your MER is bad, I'm dropping a lot of packets on upstream 3, let's go down to 3-channel upstream bonding. I'm not going to schedule any mini slots in upstream 3 because it's bad, so I'll schedule all my mini slots upstream 0, 1, and 2. So that's automatic. But what if you had a scheduled flow in upstream 3 that's voice? Because we don't bond voice traffic. We put it on one of the upstreams in that bonding group. That way it's under the scheduler. We can control jitter and latency. That voice flow will get dropped. So you have to put in these next 3 commands: cable upstream resiliency, service SF-move, which is service flow move, RTPS, NRTPS, and UGS. So UGS would be for voice, RTPS, NRTPS might be for call signaling. I don't know if anyone's using those, but some people use NRTPS for call signaling traffic. So if that's a scheduled flow and that upstream happens to go down, you want to make sure that secondary flow actually moves over to the upstreams that are still up.
Right. Yeah.
Makes
so
sense?
this is if the cable operator's providing voice traffic, right? This is all voice associated traffic that we're going to be able to now help improve the quality of service of this voice traffic. Correct?
So yeah, what I'm saying is DOCSIS 3.0 EMTAs that have an upstream problem, they go into upstream bonding partial mode, they end up dropping their voice calls.
Right.
And these commands will help keep those voice calls up.
Yeah. Now, if this is non-cable operator voice traffic, like it's FaceTime or Skype or like a Hangout, like what we're doing right now, this is not going to improve that type of traffic. This is
that
only
type of traffic is best effort. It would be
right.
bonded traffic anyway. So what would happen is they would still bond across the other upstreams that are still up.
Yeah, this only counts if it's managed by packet cable. Or
Yes.
if somehow we're ensuring that it's the voice traffic is on a unsolicited grant service, a UGS service.
Yes, correct.
Okay.
Correct. All right, and then the last command in this column is cable upstream resiliency data burst. It's like one big long line where we put all these thresholds in one command. Data burst SNR 24, uncorrectable effect 1, correctable effect 0, hysteresis 4. Let me explain what this means. It's a new command that we are now tracking the data burst MER of the Broadcom chip. We used to just look at the station maintenance burst MER. Now we can also track the data burst, the actual data. And if I put down some values I think are best. SNR, which is MER, same thing, 24 dB. And the reason why I picked 24 is because I know I'm probably doing 64 QAM. Uncorrectable FEC, 1%. That makes sense that if I get 1% uncorrectable FEC, I'm going to change something, and I'm going to explain what that change is. Correctable FEC 0 means turn it off. I don't track correctable FEC because it can cause false readings, false failovers. Hysteresis 4, I'll explain what that means. So if I'm doing 4-channel upstream bonding and the data burst MER of upstream 3 drops below 24 dB, and the uncorrectable FEC for that specific modem, now it's a per modem basis, if it goes above 1% uncorrectable FEC, that modem will say that upstream is unusable. So it will go into partial mode correctly when it gets below 24 dB MER and greater than 1% uncorrectable FEC.
And you're choosing 1% uncorrectable FEC because that's typically where, for any type of real-time services, particularly like voice and video, and well, I wouldn't say video, but particularly like voice services, that's where you can start to hear packet loss. So like that's when your voice will start to break up and the person on the other end will say, hey, I'm starting to notice your voice quality is bad when it gets above 1%. So that's when it makes sense to say, yeah, let's get rid of this channel.
Correct. So. And then the hysteresis 4 is saying, don't take that upstream out of partial mode. Don't reactivate that upstream unless the MER gets above 28, which is the 24 plus the 4 dB.
And at that point,
you're giving yourself hysteresis so you don't get thrashing where the upstream goes up, down, up, down.
Coming on, going off, coming on, going off.
Exactly.
Awesome.
So this is a nice command, and it's kind of new because before we were just tracking the station maintenance burst to put a modem in upstream partial mode. And what if that station maintenance burst was QPSK? What if that station maintenance burst was 16 QAM? Here we're actually tracking the data burst, which is probably 64 QAM.
Yep. Yeah, I like the 1%. That to me really resonates for uncorrectable FEC because that's always a recommendation I'm giving people.
Some people would argue 0.1 would be better, like being more aggressive, 1 out of 1,000, 0.1, but we don't allow that.
Yeah.
So 1% it is.
Cool.
And then the next column, I show the bonding group. So I made a 4-channel bonding group and a 2-channel bonding group embedded in the 4. Mm-hmm. We talked about that a little bit, why I picked the 2-channel as the middle upstreams versus, two-channel bonding groups. The map advance, that could be a topic all on its own. A lot of times we look at the fiber distance. We look at the time offsets the modems are reporting. And we can come up with some best practices on how to limit how high the map advance can get. Meaning, I've seen modems that start out with a time offset of, say, 3,000, and then 2 days later, they're up to 18,000. So that's a bad modem. That's bad firmware. Something is happening with the modem. It's doing station maintenance and adjusting its time offset every 15 seconds, but it's following a pattern where it keeps going up. Instead of going up and down, it's actually just going up, 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 up. And that can affect the timing and the map advance for everybody else on that cable interface. And that's not a good thing. So map advance, I don't want to get too far into it, but yeah, there are some recommendations for map advance to get a little bit tighter control of it. Setting a cap, if you will, where how high modems can go up in their time offsets. The next line was SIG cluster. If you need 3.0 modems to get, I would say, greater than 20 megabits per second on the upstream, you're better off setting the SID cluster, number of clusters, to 2. This means that a modem that does 4-channel upstream bonding, a lot of times it'll use the same SID. So it might say, I have a service identifier of 13, and I'm going to send upstream traffic at upstream 0, 1, 2, 3 with the SID 13. But
and you're saying this will help with upstream speed on the modem when you're getting above 20 when you're getting above 20 megabits per second in the upstream.
Correct. This will allow the modem to use 2 SIDs, and that way it can generate more bandwidth requests. And the next line ties into that. The next line says max request 4. So I'm saying let this modem actually make multiple requests, let it use 2 SIDs to make the request, and now you'll get much better upstream speed from the 309.
Okay, so the first command is cable SID cluster group, number of clusters, 2. So that's saying use 2 SIDs, right? And then the second one is cable SID cluster switching, max request 4. So that allows you to do 4 requests.
Correct.
Within the previous command on 2 SIDs.
Yeah. So you'll find those 2 commands. You can manipulate, try different settings, and see what your results come out to. But that will help you get faster upstream speeds from a 3.0 modem.
Yeah, and I think these are really important things for folks to listen to, because increasing the upstream speeds is something. I mean, a lot of folks have understood how to get like 100 megabits per second in a downstream, but now they're trying to get like 25 or 30 or 40 megabits per second speed in the upstream. So these are awesome commands to help optimize that.
Correct. Yeah, the next one was the cable CM status enable. A lot of times that doesn't show up because some of the CM status messages are enabled by default. I'm showing, the reason why it's popping up is because I activated 9 and 10. CM status 9 and 10 are from modems that support the battery backup and the energy management modes. So the next 2 lines actually turned on those features. And that is, if I have a EMTA, cable modem with EMTA, embedded multimedia terminal adapter, and it goes to battery mode, it can send a status message to the CMTS to put it in 1x1 mode. Because if you have a 24x4 modem, 24 downstream bonding, 4 channel upstream bonding, if it goes to battery mode, you don't want all those transmitters and receivers eating up precious energy from the battery. Right. You want to make sure that thing saves the battery as long as it can for voice traffic when it's needed. So we drop it to 1x1 mode.
And 1x1 mode, meaning it's just using it's receiving 1 downstream channel and only transmitting 1 upstream channel.
Correct. So that's the battery backup mode. And the one underneath of it takes that a step further. That was part of Cable Labs as well. It's called energy management mode. And that actually requires more settings in the CM file, whereas the battery backup doesn't really care. It just tells the CM status, the batteries, like its AC is off and battery's on. The energy management actually tracks a user configurable threshold of throughput. So you have to set that threshold in the CM file. And what happens is you could say, well, I'm going on vacation. My modem is transmitting less than 1 megabit per second over this time frame. Let's put it in 1x1 mode. So instead of having customers that go on vacation unplug their modems, you can say, I'm saving energy. I'm saving new energy out in the field. The homeowner, I'm saving energy because I'm putting it in 1x1 mode, so I can still use it for P&M. I can still use it for full bandwidth capture. I can still do, remote speed test to it. I can still do station maintenance. I can still have it in my configuration. I still have control of it. I still have station maintenance.
Now, how do you know that the customer's going on vacation to put it in 1x1 mode?
You don't. You're just saying, what is the threshold for the throughput? Okay. So if the throughput drops below a certain speed for a certain amount of time, then you just make the assumption. That there's no traffic, so I might as well put it in 1x1 mode.
Okay, yeah, that's a cool feature.
Yeah, and the modem doesn't go offline. It actually, the downstream drops to the primary downstream, so it doesn't have to change the primary.
Right. Makes sense.
Yep. So those are some features people are looking at nowadays.
Yeah, very cool features.
Mm-hmm. All right.
Ready for next?
Yeah, that one slide took us all day. So some other things I wanted to point out was we have a command. I found that let's suppose you do 24 downstreams. Well, what if all 24 are primary capable? Mm-hmm. You are replicating all the map traffic. So all the upstreams have to have downstream maps to do upstream scheduling. And you're putting all that information down every primary downstream. So when you go to 24 downstream, you might say, you know what? I'm better off making every other downstream primary to save almost 1.5 megabits per second. 24.
Yeah, so there's that argument of using secondary channels versus primary channels. And you're kind of saying this is an automatic way of doing that, right?
No, I'm saying this is what I would recommend, that you don't make them all primary anymore. There's no need for it because your 2.0 modems are going through attrition. So there should be less 2.0 modems anyway. And then if you get rid of the primary capability on some of those downstreams, you gain more speed back. The command I'm pointing out here is I wanted to point out something that's even worse. People don't understand is if you're doing set-top boxes with multicast, we'd send all the multicast down every primary. But what if your set-top boxes are relegated to only, maybe you're doing some type of cable modem steering, you're forcing the set-top boxes to maybe only 4 downstreams. Well, if all 24 are primary, all that multicast is being replicated down every single primary.
Mm-hmm.
So we came out with a command to say, all right, I can eliminate that multicast on certain primaries by putting this command in: cable downstream DSG disabled. So the primary, if you still have a lot of primaries for DOCSIS 2.0 modems and 2.0 traffic, but you're not going to do any multicast or no set-top boxes on those downstreams, you can turn that multicast off. And that multicast could be 5, 6, 7 dBm or 7 megabit per second. I don't know how much multicast.
It's a significant amount of overhead that you have going down.
Yeah, and maybe you don't even have set-top boxes going to those downstreams, so you're just wasting speed.
Right.
So that was, I wanted to point that out. The next one was service flows that don't tear down automatically. I've had some old EMTAs that I think it's a T8 timer that the customer went off hook and then on hook, meaning he hung up the phone, and the service flow is still up. So it didn't tear down from the CMTS. So now the CMTS is eating up resources. It's scheduling flows on the upstream. So we have a catch-all command on the CMTS to tear flows down that have no activity. So I was recommending turn this command on. It's cable service flow activity timeout 300. So if there's a flow with no traffic for 300 seconds, 5 minutes, then the CMTS can tear it down automatically.
Right.
Kind of a catch-all.
Good.
Yeah, I've had cases where I looked at individual service flows and found a phone call that was up for like 20 days. 20 days? Like, why is this call up for 20 days?
Yes, yeah, actually, I thought that was something that was taken care of a while ago. So this command is not on by default. This is
no.
This command needs to be enabled.
Yeah.
I need to go back and do that.
The last one was DPON best practices. So if you go to the next slide, we actually go into RFOG. DPON is DOCSIS passive optical network, also called RFOG, RF over glass. There are some specific settings and recommendations for a DPON system, RF over glass, because if you don't have proper settings, you have all these lasers potentially coming back on the upstream, colliding with each other, causing OBI. OBI is optical beat interference. So if you get an optical beat interference, depending if the optical link is AM, amplitude modulated, or frequency modulated, you're either going to get lower MER or potentially for FM system, frequency modulated laser, it'll just knock it out completely. So you can't have your neighbor doing 2-channel upstream bonding with upstream 2 and 3, and yourself doing upstream bonding with upstream 0 and 1. Because now his laser will come on independent of your laser. So those two lasers at the same wavelength, they're going to collide, cause OBI.
Right. And it's not just lower MER. I mean, it's uncorrectable code word errors, right? It's really bad things for the subscriber that they're going to experience.
Yeah, so OBI is a bad thing, and you can get some type of filtering, or you could just say, let's have this type of scheduler so that all the upstreams in the bonding group are really sort of one scheduler. So our Cisco CMTS, we came up with a command called cable upstream DPON, and that actually turns on this RFOG scheduler, and it's on an interface config now. So we have some recommendations on getting the proper DPON work, and I even have recommendations on mod profiles. What we found out is the lasers turn on and off really fast, and the laser turns on fast enough, and that's not the problem, it's turning off. What we found is one laser will turn off kind of slowly as the next one turns on, and you get uncorrectable effect. So we came up with some mod profiles to create more guard band and time delay between the upstream bursts. That way, if I have a little bit more guard time at the end of an upstream burst, even if the lasers come on and off and overlap a little bit, that time frame there was null bytes. That makes sense.
Yeah, absolutely. Yeah. And so when also enabling this, you're just ensuring that the lasers, when they're transmitting, aren't transmitting on the same upstreams at the same time. You're forcing one to transmit on upstream 0 while another one's transmitting on upstream 1, right?
A laser doesn't know the difference between an upstream. It doesn't know.
I'm sorry, it's not the laser, it's the modem. It's the modem bursting on upstream 0, upstream 1.
Correct.
Thank you, John, correcting my ignorance.
So to kind of put it in perspective, if you do an RFOG network, they should all be DOCSIS 3.0 modems. You shouldn't have any legacy set-top boxes. You shouldn't have any 2.0 modems. If you do have 2.0 modems in set-top boxes, they're all relegated to Upstream 0. We force them all to Upstream 0. So basically, you lose all the capacity of DOCSIS 2.0 load balance.
Right.
So the only thing
and
this
you're going
really
to
does for
congest.
you,
You're going to overly
yeah,
congest Upstream 0 in that case.
Definitely. So your best bet is all DOCSIS 3.0. Let the modems burst from Upstream 0, 1, 2, 3, and get faster speeds, and then they can share that speed.
Yep. All right. Good stuff.
All right. Next slide. I think we're almost done. Now we're going to fly through the stuff. This was just some new features. Whoever downloads the slides can look at some of these features. I'll go through the remote PHY devices. Is RPD, remote PHY stuff is coming out now. The data burst MER, I actually talked about that in the cable interface configuration. We now support 16 upstreams per MAC domain. So if you're doing multiple fiber nodes per service group, and you want to do, say, 5 upstreams on one fiber node and 5 upstreams on another fiber node, that's 10 upstreams. Well, now we support that. Before, we only supported 8 max. The energy management mode, I talked about that a little bit. DOCSIS 3.1 upstreams coming out. 3.1 graceful profile management. That's a cool one where the modems now, for DOCSIS 3.1 downstream, they could automatically drop from, say, 4K QAM to 2K QAM to 1K QAM and then upgrade themselves. So they don't go offline. You can have some modems that are end-of-line modem with poor MERs being reported back to the CMTS on all those little data subcarriers, and the CMTS can make a decision, hey, you're not appropriate for a 4K QAM. Let's drop you to 1K QAM. But your neighbor is actually still working at 4K QAM, so we'll just leave him at 4K QAM. So we can get a lot more capacity for the guys that are good and not have to drop everybody down just for a couple bad apples.
Now, you're almost getting into the point where you could do this on a modem by modem basis, or how granular can you get with the ability to handle individual problems with modems?
But we're finding that keep it simple, stupid. That principle, KISS principle, keep it simple, stupid. The modems only keep 4 profiles in their NVRAM plus the control profile. So we're better off just doing 4 profiles. And I really think it's going to be 4K, 2K, 1K, and maybe 256 QAM, or maybe 512. Maybe not even that. Maybe 256 QAM as a control profile. 1K, 2K, 4K, and maybe a mixed mod profile. So I basically have 4 major profiles, and modems are reporting their CM status messages for the MER of every subcarrier back to the CMTS, and the CMTS can make a decision. Are you better suited for 4K, 1K, 2K? Maybe you're so bad that I'll force you on the control channel of 256 QAM. But hey, maybe you have roll-off. Now throw that mixed mod profile in just because you have roll-off. So I think that's where things are going. Right. So it is a per modem though.
And when you say 4K, that would be 4K for all subcarriers if the modem can support it. If not, Correct. It would drop to 2K for all subcarriers for that Correct. Modem. So it's basically impacting all subcarriers. It's not like we're going to say, okay, these first 200 subcarriers are going to operate at 4K. These next 2,000 subcarriers are going to operate at 1K. So it's not kind of like every subcarrier is going to have its own modulation. We're kind of going to bounce. It's going to apply it across all subcarriers.
Yeah, and I give an example of that last mod profile being a mixed profile. That one might be, how your RF plant is. It rolls off at 750 megahertz. You might decide to be safe, a 2K QAM from 600 to 740, and then 512 from 740 to the rest of the 192 megahertz block. Because you can have roll-off. But that is only going to be used by modems that need to use it.
Yeah, and for anyone listening, when we say 2K QAM, that's 2048 QAM. 4K QAM is 4096 QAM, and we're saying, well, what is that? We're kind of keep increasing these, so we're starting at 256 QAM, 512 QAM, 1048 QAM, 1024 QAM, 2048 QAM. They keep going up. These are all functions of 2 to the factor of something. So that's where we come up with these numbers. We're not just randomly making them up. Although John makes up a lot of things, I try to stick to the facts.
I mean, we're just making it more complex to get more speed out of the same bandwidth, same spectrum.
Yep.
Right. And actually, you talk about the modulation stuff. To go to the next slide, I think I go into the 3.1 stuff a little bit more. There's a couple settings that we found the 3.1 is so robust from LDPC, the low density parity check. and the time and frequency interleaving, that we are able to potentially ignore a certain percentage of subcarrier MERs and not have the full OFDM block change just for a couple bad subcarriers. The default's only 2%, but we're finding that as a best practice, we're thinking about setting it to 10%, because the LDPC is so great. The time and frequency interleaving of the packets and the subcarrier stuff information is actually correcting quite a bit when we have ingress, and we have, say, ingress from LTE, the long-term evolution 4G cell phones, that changing from 4K to 2K QAM just because I have 2 megahertz of ingress is actually a detriment, meaning I don't really need to, because I'm not seeing packet drops anyway. So we're thinking that 10%, ignore 10% of the subcarrier MER, and then look at the rest of the 90% of active subcarriers to make the decision of whether to drop to 4K or 2K or 1K QAM.
Right.
And even the MER readings, so that it's based on how much do I ignore and what is the MER thresholds. Well, the MER thresholds are based on the DOCSIS 3.1 spec, which turn out to be about 6 dB more conservative than they really need to be.
Yeah.
So we have a CMTS, what would you call it? Just a kind of ignore or a threshold correction factor, if you will, in quarter dB. So I've been setting that to 12 quarter dBs, which is 3 dB. So I'm like, if 4K QAM can up, the spec says 41 dB, I'm saying don't change my modulation 4K down to 2K unless it drops below 38 dB MER.
Yeah, so I mean, basically what we're hearing time and time again is that DOCSIS 3.1 is working better than we even thought it would work, working better than what we put in the DOCSIS specification, and saying, yo, we need this minimum MER for the data to go through, for the to actually perform in an impaired environment. It's exceeding the MER because of the LDPC error correction. Now we've moved from the Reed-Solomon error correction in earlier versions of DOCSIS. Reed-Solomon was it was an okay error correction. LDPC is just a phenomenal error correction algorithm.
And we're finding a lot of systems could successfully run 4K QAM with the functionality of graceful profile management. Because you can't just arbitrarily turn on 4K QAM and say everyone's going to be able to use it, because you're going to have some end of lines that are bad. You're going to have some frequency response problems in certain houses. But having this graceful profile management kind of covers all that. And so awesome. once you have some modems that drop down in modulation, then you go troubleshoot those modems.
Yep, fix those homes or the end of line issues, and now everyone can be a 4K QAM.
Yeah. I mean, it's a lot more functionality and flexibility we have now versus DOCSIS 3.0 and 2.0. The other next bullet point was correctable FEC. I wanted to point out with DOCSIS 3.1, you're going to get a lot of correctable FEC. So don't use that as any gauge of the plant health. Because with DOCSIS 3.1, how LDPC works, all the packets, the symbols, the subcarriers, you're going to get a lot of correctable FEC. That does not indicate that you're getting close to uncorrectable FEC at all. So don't be scared when you start seeing 100% uncorrectable or correctable FEC. It's the uncorrectable we're worried about.
Yeah. Basically, I mean, to summarize, LDPC is always going to well, not always, but if there's some impairment there, it's going to say uncorrectable FEC, but wait, let me iterate one more time, and I will be able to fix some of these correctable FECs. So it iterates again, and it's able to fix some, and maybe it has some correctable FECs left. It iterates another time, and it fixes more of those bits, and it keeps doing that over and over until it corrects all the original bit errors that it had. And that's the cool thing with LDPC. Instead of just trying once and saying, yes, well, we have FEC errors, and giving up, it does it over and over and over again. So to your point, you're always going to see that we have some correctable FEC errors. Don't get upset about it.
Correct. And then the last bullet point was kind of a did you know type of fact that when I start deploying some 3.1 modems, the time offsets were extremely high. Then we've realized that DOCSIS is based off a 10.24 megahertz clock, but DOCSIS 3.1 is based on a 204.8 megahertz clock. So if you do the math there, 10.24 versus 204.8, it's a 20x different. So what we're seeing with the time offsets of 3-1 modems, they're showing 20 times more time offset. Now that is not being used for the map advanced calculations. We actually just divide by 20 and we use that for map advanced calculations. So if you see 3-1 modems with time offsets of like 18,000 or 40,000, don't be too concerned.
Yeah, but that increased clock, that gives us a lot more accuracy. I mean, the timing accuracy is supposed to be much better, correct? In
Correct.
DOCSIS 3.1?
As my understanding, yes.
Yeah. So, that was a lot of good information, John.
Yeah,
a lot of good material in that presentation.
Thank you. It's a lot to go through.
Yes, but it was part 3 of a 3-part series of presentations. So if we rewind all this, we've got really a good series that we went through there. So tremendous amount of good information. Thanks so much for all the time and effort you put into that.
Yeah, definitely.
So,
and then the 3.1 stuff, we're going to go over. That's part of my, and hopefully you'll be in there as well. You're supposed to be co-authoring with me the SCTE Expo paper on DOCSIS 3.1 downstream lessons learned.
Yes.
So I submitted to Prezzo. I'll probably convert some of it to a paper, and you and I can add some stuff to it, and then we can point, some of the audience here to that paper and presentation.
Absolutely. I'll be going over the presentation this weekend, and I'll start working on some stuff with you as well.
Sweet.
All right. So, John, thanks again for a wonderful 15-minute session. As we always plan these, we went an hour and 16 minutes. Thanks, everyone, for joining us, and we're going to call this a wrap. Time to get back to work. So we'll sign off. Take care. Farewell.
Thanks. Arrivederci.